This video describes the current status of the JTAC Strike project being developed for the Air Force Research Lab by Energid Technologies. It describes the technical approach being taken and the working aspects of the prototype. This presentation includes some samples of the prototype in operation. These samples demonstrate the functionality of the system, but are not representative of all aspects of the final product. Energid's JTAC Strike is a standalone, PC-based interactive training system with sufficient fidelity to enable full mission training, dramatically impacting JTAC's combat mission effectiveness. The system permits a realistic training environment on a standard computer, making training accessible anytime or any place a standard computer is available. JTACs can perform an entire virtual CAS mission from mission planning, mission preparation, to execution and debriefing.
Gunslinger, authenticate Bravo Hotel November.
Hog, I authenticate Romeo.
Gunslinger, Dog is checking an extract. Current position 2.5 clicks west of IP Bravo. Gunslinger, playtime is 30 mics. Gunslinger, hijack the 9-line you set. Say when ready for reback.
The JTAC's interface with the simulated pilot is pure voice communication and enables a JTAC to participate in realistic dialogue with a pilot intelligent agent. JTAC Strike will enable the Air Force to cope with a growing demand for combat-ready JTACs in an era of limited live training opportunities. Live training is time-consuming, expensive, and inherently dangerous. Traditional simulated training requires a team of support players as well as dedicated equipment and facilities to create the complex scenarios needed for JTAC training. Voice input by the JTAC is either via a standard computer headset or by using the system's H250 handset adapter, allowing an extra degree of realism. As the simulated terrain is DTED, the JTAC can use either a standard paper map or the system's digital map, again adding to the realism. The simulation's speech recognizer, parser, and dialogue manager listens to and interprets the JTAC's dialogue input. The virtual pilot responds verbally and reacts visually in a realistic way. This unique dialogue visual context system is at the heart of JTAC Strike's architecture. Our technical approach will work in traditional CAS and in urban CAS scenarios. JTAC Strike includes a scenario developer toolkit designed to allow subject matter experts to build and distribute new training scenarios. It also includes an extensive library of background information that the JTAC can reference in preparation for his mission. The JTAC trainer provides a full mission scenario where the JTAC starts out by getting the mission brief, then mission plans, packs his ruck, and moves to the OP. At the OP, the JTAC checks in and authenticates an aircraft, passes a 9-line to the aircraft, and then gives a talk-on to a target. Assuming the talk-on is good, the aircraft will then engage the target. Once the mission is completed, the JTAC will be debriefed on his performance. JTAC Strike software interprets and interlaces communications, environmental context, and background knowledge. With voice vision-enabled intelligent agents and voice input from the JTAC, these references are continuously updated in a multimodal context system as a result of mutual perceptual and linguistic events. The software combines spoken dialogue with a 3D spatial reasoning module based on rendering the environment with synthetic colors. JTAC Strike's innovative multimodal context system forms the heart of the system's architecture. Drawing from vision and language domains, it interleaves communication with environmental context and background knowledge. Using our architecture, the pilot intelligent agent can reason about and understand his environment in a manner similar to a real pilot in a real-world scenario. This enables our unique JTAC learning environment. The vision component is solved by the Virtual Pilot Synthetic Vision module. This synthetic vision enables 3D spatial reasoning using a technique which takes advantage of the graphics architecture of personal computers. In our false coloring technique, each object in the environment is assigned a unique color, or vision ID. This color differs from the normal colors used to render world objects, hence the term false coloring. Instead of a real scene, an artificially colored scene with the same physical dimensions is rendered. By scanning the false color scene and extracting the pixel information, we obtain a list of objects currently visible to the pilot. We can also derive measures of visibility and prominence using a visual salience algorithm. The dialogue module manages voice communication between the JTAC and the pilot intelligent agent. It consists of a speech recognition module, parser, and dialogue manager. It tracks speech context and resolves ambiguities commonly encountered during CAS missions.
Gunslinger, I have the night line you sent. Sailing ready for reback.
Hog, go ahead.
Gunslinger, Hog did not copy.
Hog, go ahead with the readback.
The dialogue module provides processed input to the multimode context system. The simulator replaces supporting players, such as pilots and ground commanders, with intelligent agents. The agents make decisions based on what is known about the user and the state of the game. The system's intelligent tutoring module interfaces with software agents to make judgments about what the JTAC student knows, how well the student is progressing, and how to tailor instruction to that student. The multimodal context system brings all of this together, monitoring the dialogue between the JTAC and the agent pilot and continuously referencing it to what is seen by the agent pilot. The layering of the false color interpretation of the environment enables pilot reasoning and initiates dialogue for resolution of ambiguities. The language vision context system forms the functional back-end to the training simulator.
Hog, say when ready for talk on.
Gunslinger, home of talk home.
Hog, call contact.
The context
Dry Lake
system
Bend,
enables the
north.
JTAC to guide the pilot's eyes through simulated terrain onto a target using either a funnel approach, also known as big to little, or using another common method called unit of measure.
Hog, let's establish the east-west extent of the lake as the unit of measure.
Gunslinger, copy.
Let's establish the western limit of the lake as the anchor point.
Gunslinger, copy.
Take the unit of measure and go 1 unit to the west.
Gunslinger, roger.
Take
The
unit of
pilot
measure
agent
and go half
reacts to
unit
the
east.
JTAC's verbal cues to acquire the visual objects in the scene. This dynamic enables the JTAC to successfully talk the pilot onto the target.
Gunslinger, contact.
Hog, T-55 is on the western side of the dirt ball intersection.
Gunslinger, tally T-55. Departing might be at this time.
Hog 01, say status.
Gunslinger, landing down to target.
Hog copy.
Gunslinger, Hog is 60 seconds out.
Hog continue.
Gunslinger, say status of T-55.
Hog, T-55 is stationary. Continue.
Gunslinger, copy.
Hog, you're cleared hot.
Gunslinger, copy. Cleared hot.
Energid's JTAC Strike provides an easy-to-use training system combining advanced linguistic and vision techniques into an interactive training package that is designed for today's complex training environment. Energid's JTAC Strike solving the needs of the U.S. Air Force for combat-ready JTACs by providing advanced training anywhere, anytime. Energid, providing solutions for the training needs of today and tomorrow.